So, hi everyone. Thank you for being part of this Additive Talks session dedicated to personalized medicine with 3D printing and robotic surgery. I am Katie Sinze, managing editor at 3D Adapt Media. So, unlike our previous Additive Talk session in this vertical industry, we are not going to give insight into the use of AM for medical devices, but rather focus on various stages and types of surgical procedures that may require the combination of 3D printing and robotic surgery. The ultimate goal today is really to assess the impact or the use of 3D printing in medical procedures and try to, help you understand how you can make the most of both technologies. Around this virtual table, I have the honor to welcome Professor Jan Wolf and Henry Pinchberg. So good afternoon, gentlemen. So, Professor Jan, could you please tell us more about you?
Yeah, good afternoon. Thank you so much for having me here. Greetings from Denmark. I'm actually at the moment at Aarhus University. By trade, I'm a maxillofacial surgeon, been working in the field of additive manufacturing for at least 25 years, if not more. And currently, we're also in the process of applying and adapting robots in our environment. And that's basically, in a nutshell, my background. And I'm looking forward to having a really nice discussion with Henry.
Thank you very much, Jan. What about you, Henry? Tell us more about you.
Hi, nice to meet you, Jan, and nice to meet you, Ketty. I'm a lawyer by training, but don't hold that against me. But now I run a little company called 3D Life Prints in the UK. We're one of the UK's leading medical 3D printing companies. So we deal with design and manufacture of patient-specific medical devices on a daily basis. And so I know a fair amount especially about regulations. I'm good on regs, but I'm also good about the marketplace, about where it's going in the future, and how I sort of see these two marketplaces, robotics and a medical 3D printing, perhaps working together, or perhaps even complementing each other, perhaps being alternatives to each other. So very happy to talk all the way through these subjects. I can give you an introduction to the company as well. You just tell me, Ketty, what you need.
Thanks, Henry. I'll let you know. So quick reminder for our audience, you have a Q&A chat in front of you where you can ask any questions, where you can share your remarks, whether or not you agree with things that we will discuss right now. And we'll pause at some point along the conversation to read and comment on what you will have asked or what you will have shared. So we have professionals from various backgrounds, as I said, while listening to us today, and to help them situate themselves, around this topic. Professor, what are the different fields of activity or cases where it can make sense to combine robotic surgery and 3D printing?
Well, that's a very good point. I think there's synergies between both technologies. And if you look back a little bit, I have to take you back a little bit in history.
Yeah.
And understanding the whole development of these technologies. Basically, it was 1985 that 3D Systems actually went through the process of assessing if it's possible to take an image and translate the image into an STL file and use it for 3D printing. This is a history. But in that context, there was a big development, and there's been a big development in using 3D printing. But the interesting thing is the blueprint of 3D printing, you could say even augmented reality, virtual reality, and robotics is actually image data. So CBCT, CT data. So we're using the same blueprint for different aspects. And nowadays, if you're actually planning surgery using a robot, you're basically using the same data that you'd be using for 3D printing. So
Okay.
it's you have to see this in a bigger context, and it's basically the same technologies that you're also using nowadays for virtual reality and augmented reality. So the interesting thing is we're using the same blueprint that was actually described in 1985, and where we are translating different color scales into an STL model, and this STL model is basically then used for virtual planning. So that gives a little bit of maybe a context about that robotics is just a natural development of a technology that dates back to 1985, around that time. So that's a little bit of a background. I don't know what you think about that, Henry.
Well, I think I totally agree, Jan. I mean, I call it sometimes the raw material,
Yeah.
right? What's the raw material of our marketplace? And people think it's 3D printers or plastic or metal. I'm like, no. The raw material is patient data. Without patient data, there is no anything. You can't start a project. You can't make a custom-made medical device, or indeed, at the minute, do anything with robotics, as far as I'm aware. Although I have to say, I'm no expert in robotics. You can't start any of those projects without access to patient data. So I totally agree with you, Jan. I think that there's several technologies that spring from this, and again, I think there's a lot of misunderstanding around the marketplace, especially outside of the medical fields, or even within the non-specific parts of certain fields, like CMF surgery. It tends to be most CMF surgeons have got a pretty good handle on what medical 3D printing means. But if you ask, I don't know, let's say most orthopedic surgeons who are doing standard hip surgery, they may not totally get it. And if you're asking someone who's in an unrelated field in medicine, they totally won't get it. If you ask a general practitioner what medical 3D printing means, they'll say, I don't know, printing syringes. And it's actually got nothing to do with the printing process at all. It's the process of taking a scan data, segmenting the scan data, designing upon the segmented scans, and then producing an article at the end. That's what we talk about when we talk about medical 3D printing.
Okay, I hear what you said, but with the rising usage of 3D printing, in increasingly automated surgical tasks, is it fair to say that 3D printing helps automation of robotic surgery, or is it the other way around? Henry?
So I think you've got to break that down a bit as a question, because 3D printing has several different kind of product categories, I suppose is the way to say it. And only some of them may interact correctly with robotics. So if you break down what you can do with medical 3D printing, so first category, anatomical models. I think everyone understands this, at least if they're on this webinar, they should understand this. It's where you've got a copy of a patient's anatomy. The second category is surgical guides, which is a little bit more involved, which involves translating a digital plan into a product. And the third category of custom-made devices. And I think it's the middle category, surgical guides, that kind of is almost a competitor to robotics. Now, Jan may have more, because he's a surgeon, may have more kind of comment about which one works better or how they work better. But in my mind, if you're looking at something that competes with each other, it's probably only the middle category. The middle category surgical guides, they're the ones that kind of do the same thing as robotics.
I absolutely agree. And this would be like a classical surgical guide that we use.
There we go.
And this is a saw guide and a drill guide combined.
Yeah.
And I'll just show you. Can you hear me?
Yes.
Okay. And this is another surgical guide. These are classical guides that we do use on a common basis. And basically with a robot, you have the opportunity of maybe discarding the guides, but nevertheless, the process and the whole planning process is the same. So at the end of the day, you're not pressing the printer, but you're pressing the robot to do the task at hand. So robot has the opportunity of maybe being a little bit more precise in specific areas of interest. But I think it's in certain situations, you need a combination of 3D printed constructs, maybe as spacers, as holders, as implementation, and a combination of the robot. So I think that you can see them as synergies, but also as two different entities. And as Henry said, it's the middle part that is sometimes discarded in robotic surgery, but not always. It doesn't necessarily mean that an operation is completely without 3D prints, because actually we do place like reconstruction plates. This is a big part of the lower jaw. We actually have to place certain constructs after the robot has done its job. It's done its work. So then you need to place material in the body so it stabilizes the whole situation.
Okay.
Can we just talk about money there as well? I mean, we're having a commercial entity, and I think it's important that we get it out there and talk about money, because robots are wildly expensive, right? They are wildly expensive pieces of kit. Now, and there's some very big companies out there selling some very good robots. We work with several of them, and but even on a good day, they'll cost you, the thick end of $1 million to buy. So you may get some great results with robots. I'm not disputing that, but I think sometimes you've got to think about, what do you want from a robot? I mean, what's the output going to be? And if the output is just a surgeon wants one, it's not quite the same as you saying, okay, what you want is better surgery, more accurate resections. And sometimes you can achieve the same thing using surgical guides, and the average surgical guide costs you, I don't know, £500. So you're kind of not comparing chalk and cheese there. They're two very different things in terms of the money that may achieve the same result in the end.
Yeah, and I was about to ask that, Jan, because when I hear you, it's like we can use, robotic surgery. I mean, a robot prior to the surgery, and I wanted to ask, what are the main factors to consider when choosing a robotic tool for surgery? Is it only, a tool that we can use prior to the surgery, prior to entering the theater room, or during the theater room? Could you please just provide further information, resources on
Well,
that?
it's all under development, and at the moment we're actually working very closely with robotic surgery in the field of laser guided robots. So these are just cutting robots, and lasers are very interesting. And the interesting aspect is that during the operation, you can actually halt the machine, and you can assess the situation, reassess the situation, and you can change the plan of the operation. So this makes this is a very, very important task. So what we do is we try to cut, especially in the lower jaw, we try to do what you call osteotomies of the lower jaw, and the specific methods of using like laser guided robots, and that's what we use, a so-called Carlo ablation robot that is made in Switzerland. That's one that we're actually working on. And we do see that there are certain tasks that it's really good at. And that is, first of all, very precise cuts. Second of all, puzzle-like cuts. So you can do osteotomies in all different directions. And I think one of the most important parts is the ability to interact and change your plan during the operation on the fly. But the planning system and what Henry does, and at the end of the day, if you're buying the product, and it's all the same. So the amount of work you put into it, and if you get a product that is a 3D print, or if you get a professional to guide your robot, it's both a tedious task. It requires a lot of knowledge. So I think that it's just you have to see this as a kind of an opportunity or extra opportunity we have that we didn't have a few years ago when it comes to robotic surgery. But we're not that far that they're autonomous and they just go and everything is fine. That's not the case. But
okay.
Can I ask? So when you're planning one of your robotic surgeries, who does the planning? How long does it take? What software do you use? That kind of thing. Because I don't know about robotics particularly. I know about 3D printing in our process, but in that process, like how do you get from your DICOM through to your plan?
Exactly the same. So we convert the DICOM data into STL data sets, put it into a special software, and then we virtually plan. Instead of planning the guides like this, we just plan a clear osteotomy line, or whatever you'd like to call it, and the planes, and we just describe the planes, and the robot does the rest. So we use mimics, thematics,
the normal
geomatics, conversion, depending what kind of software you want to use. Medviso, there's endless amount of. So we're doing exactly what you're doing in your company, exactly the same. So the requirements are the same, and that's why I do see this as an opportunity in the future for companies to take over certain tasks, especially in complex operations, with a little bit of an advantage that you can redo and reassess the operation on the fly.
Can I show you? Can I share a screen for a second, Ketty? I don't know why. If that's allowed here.
In a minute, you can share. I just wanted to ask Jan, who performed these tasks, Jan? Is it you, the surgeon, or you have a biomedical engineer who does?
Biomedical engineers are.
Exactly.
It's a combination of surgeons, just like as it is at the moment when it comes to 3D printed constructs. It's the classical same situations, the same people. It takes them 20 minutes to adapt to the new technology, and they basically understand what it's about. So that's the interesting part, that you can use knowledge that you already have. And the implementation of a robot is not that difficult, but you need professional people like Henry in the background that really know what they're doing, so medical engineers. And that's probably going to be a new task in the future.
Perfect. Yeah, Henry, go ahead. You wanted to share something.
Yeah, only because just to kind of back up what Jan was saying there, I was going to show you a complex case in our platform where we have done the surgical plan and created some guides. And just what Jan was talking about, these cutting planes, that's exactly what we do. We go in there with the surgeon, we agree on, here you go, I'll share now so you can see what I'm talking about.
Yes, you can share your screen and
let's try.
And those who are listening to us can also enlarge your screen, yes, in order to see what Henry is going to show us.
Okay, so here we've got a complex. This is orthopedic surgery, and in traditional surgeon speak, this probably means nothing at all to Jan because he's a craniofacial surgeon. Hopefully he gets it though. Okay, so you can see here what we've got here is a large tumor of the pelvis that's picked out in red, and you can see what the surgeon wants to do. He wants to resect the tumor. This would be exactly the same, honestly, in a CMF case because you have a piece of bony anatomy that needs to be cut out, and you want to choose where your cutting planes go. So what we would do here with the surgeon, we decide exactly on how far this tumor, boundaries of the tumor, he wants to cut from there. Normally a millimeter or something, sometimes half a millimeter. He wants to go from the boundaries of the tumor. We would then, with them, have done all of the segmentation work. We would then do the virtual surgery with here, which you can see here. This is actually relatively simplistic, honestly. There's only 2 guides here, and we would then determine these cuts here. It would be more complicated, for example, if you wanted a guide here as well on the bottom and another guide here along the top. But in this case, this is all we wanted. And we then design these cutting guides, which are the blue things here. You can see them picked out there. And this allows the surgeon to then have these devices, which he uses during surgery, bolts them onto the patient, in terms of these attachment points here, which we've picked out for them, and then are able to resect the cancerous section as easily as possible and with as much accuracy as possible. And Jan will be very familiar with this kind of thing. He'll have been doing it for years in the craniofacial world. But hopefully that, in terms of like visually, shows you what's available through our platform. And we do this for cases every day around the UK and in the EU now. Admittedly, we do mostly super complex stuff, but it works for less complex stuff as well. Okay, so hopefully that's given you a bit of an idea about kind of how it kind of works in 3D.
But Henry, is it a specific software platform that you guys have developed, in order to?
That's our software, yes.
Okay, all right, great. So, Jan, how do you make sure the surgical results, performed by a robot, and how do you compare them with those produced by a human surgeon? I don't know. Yeah. My question makes sense.
Yeah. So interestingly, I actually have a PhD student as we speak who's looking at the outcome of these operations. So we have quite a plethora of different operations performed over the last years, and now we're looking at the planned and the actual planning and the surgical outcome. And then there's also everybody reacts different in after an operation. So we have also a little bit of a task when it comes to that, because there's the bone reacts different to surgical approaches, and that's something in the future we would like to see. Because we want to understand also, using machine learning, predictive analytics, where do we want to go? So machine learning is now starting to become a bigger part. That is something we want to use in clinical settings and for just things. But the question is, your question was, how do we control that a robot is doing the right thing? Because it dates back to 1985 when I was working in Germany. There was a robot called RoboDoc, and the problem with the RoboDoc is that it wasn't achieving actually the planned operations, and it was taken off the market. This was many years ago. And nowadays, we just have to assess visually if the robot is actually doing what it's supposed to do. So if you have a big space and you know what you're doing, you can even take a pencil, and we sterilize pencils sometimes and show them, or use a cutting guide first and just have a certain thing. So the big thing is what you call a digital twin or augmented reality. With augmented reality and sensors, you could see if the robot is actually cutting what it's supposed to cut. So you'd be able to see with augmented environment and having a surgical digital twin, you'd be able to see if the robot is actually doing what it's supposed to do. And that's a task that everybody has to now start working on. It's autonomously letting the robot do what he wants. A robot doesn't have the same haptic feedback. It doesn't have the same dexterity as a surgeon. So you never know if it's going off or if it's deep enough or anything. So that's something very important that we have to assess, is how are we going to control the robot? And I think nowadays the tracking systems in augmented tracking systems could be very interesting, but also digital twins with certain sensors giving extra information to a digital twin that's saying, okay, you're off track or you're not off track.
Yeah.
These things do exist, but in the car industry, it's just a piece of metal, and it's always the same thing that happens.
But how long it might take before we can, effectively, assess the results of these combination of those?
The combination, I don't know how long it'll take, but it'll take quite some time. Am I frozen? Is my picture frozen?
No, fine. At least I do.
No.
One of my questions, Jan, is I know there've been quite a few papers out recently about I think it was total knee replacement and actually measuring whether robots were more efficient or more accurate than humans. And actually, it came out that actually they weren't significantly different. And I think this is kind of one of the problems with both technologies, really, is we're applying these technologies mostly in centres like yours, like the centres I work in the UK. We have great surgeons. I mean, really good surgeons who are just, really good at their jobs. And compare the robot to these good surgeons, they're going to be pretty similar because the good surgeons are not making that many mistakes. And so, so therefore, I think that we're applying them. And if you look where all the robots are, they're in all the best centres. Of course they are, because that's the centres that can afford them. So I think the thing that both technologies do is they bring up the average of bad surgery, which does happen around the world an awful lot, to a better level. I'm not sure whether actually at the minute the robots, when you look at all the literature, are actually improving the level of surgery from the humans. And there's lots of papers out there saying there aren't. So I think that when you're measuring robots, there's several things to measure against. You don't just measure whether they're following the plan. Are they better than humans? Are they better than cutting guides? I mean, I don't think there's been many studies done at all about whether a cohort of patients that are in craniofacial that have had cutting guides, you go and measure the outcomes there. Then you have another cohort the year later, or as close as you can, for a load that have measured under robotics. And then measure the outcomes of the two of them. You need big numbers for those, because obviously there's going to be lots of variables in the middle. But I don't think there've been the kind of studies on the kind of meta scale that allow us to definitively say one technology is better than the other, or in these kind of cases you should be using cutting guides, in these kind of cases you should be using robots, in these kind of cases honestly it doesn't make any difference. You should be going, but registrars should be doing these kind of cases.
Very good point, and I think we're at the beginning of a new era of technology, and if we can combine it with a lot of different things, machine vision and machine learning and all these other different aspects, then it starts getting interesting. But we're still at the beginning of this complicated task. Just like in the car industry, we're not at level 5 yet when it comes to autonomous driving. We're still maybe at level 3 or whatever. But I do think, and this is something, just an observation, or let's say preliminary observation, that we've seen, there are certain tasks that the robot can do better, and pure coincidentally we found out.
Like
so
what?
We're still working on it, but there's certain cuts. I don't want to just be too public about it yet, but there's certain cuts that we were surprised that it worked better than we anticipated. So we were probably on the wrong track when it came to our concepts and ideas. I mean, obviously, everything that is very deep inside the body, or you don't have access to with a laser or with any surgical tool, that's always problematic. But everything that's on the surface and easily accessible, then you can start looking. So what we're trying to do now, before I'd like to publish it in the near future, and you'll get that, everybody will get the results.
Okay, please share them with 3D Arab Media as well.
Yeah. The idea is that you have to identify certain tasks, and I think that's exactly what Henry said, that are probably more interesting for robots and other tasks that are not. Okay. And maybe we just need for specific tasks, repetitive tasks, or tasks that require extremely precise incisions, but then you need also depth control. And it's also identifying them. But we do think that certain cuts in the face are absolutely easier with a robot than they are, but it's a lot of planning. It's exactly the same amount of work you put into it. So we're at the beginning of a new era of technology, and it'll take another 10 years till we are actually as efficient as we are. I mean, these things have been in the market for at least 15 to 20 years. and they have proven actually their standing and their excellent outcome. And no surgeon wants to operate nowadays without surgical guides. I think that's and I'm happy that it's just become generic, if you may say so. But I think robots surely do have certain advantages, and the price will come down. But it will only be something for specialized centers and only something for highly complex cancer patients. That's where I think the future lies. That's my opinion.
Okay. Thank you, Jan. I hear you both, but I wanted to I hear you. I hear both, and I know there are some interesting pros that we can really highlight. While talking about robotic surgeries and the combination with 3D printing. But can we discuss the share of challenges that may occur in such operation?
Okay, I can certainly share in terms of 3D printing.
Okay.
I think first is as 3D printing progresses, from anatomical models at first, it's moved through cutting guides. We didn't even talk about custom implants really yet. And then we're going to get down from custom implants. We're going to move into sort of bioprinted implants that have got like a chemical formula or as we move through these categories, 3D printing will become bioprinting over the next 10 to 15 years. So I think there are certain things that robotics can't get involved with. And I think that 3D printing over a while will probably move out of the diagnostic anatomical models, maybe even out of the diagnostic cutting guide stage. But I think you'll actually move into the product stage, into the device stage, where you're actually making more device implants, basically, by 3D printing processes. So I think one of the challenges there is in my industry, I'm telling people all the time that medical 3D printing is not about anatomical models, which they all think it is. I need to tell them that actually it's about the process of the medical industry, hospitals becoming comfortable with 3D printed products as we go through the various iterations of these types of products. So I think one of my jobs, and probably Jan's job as well, is to make sure that the medical industry is educated enough and hospitals are educated enough to understand that there's a series of products and devices coming down here, and you can use each one of them as they become available more readily, and the price point becomes right as well. Mm-hmm. So I think that's a challenge for us.
I'd like to take it one step further. I think in the future that in vivo printing could be a very interesting aspect, and to print inside the body directly into the body using a robot, and that's the best of both worlds. So you'd be using a scaffold-like structure and printing it straight into an environment, or gluing pieces of bone in the right position just for a certain time, and then removing it again. So I do believe that these technologies are slowly going to come slowly into the body and closer to the body, and in the future it's going to be a combination of both.
Okay, yeah, and you just mentioned another advantage of these technologies, and I'm very glad because I'm not the only one, to wonder about the limitation of this, because in the Q&A chat, we just received one question from Magradi, with asking, the other limitations, to the use of these technologies. And furthermore, he asked for patient feedback, regarding this.
So did you say regulations, or did you say
no patient feedback? In the Q&A chat, you can read the questions from one professional, from one of our attendees. So have you seen it published? Very interesting panel discussion. Thank you. I suppose the use of robotics. Yeah.
Okay. So limitations. Well, at the minute with 3D printing, we're limited a bit in soft tissue scenarios.
Okay.
So soft tissue, when we're talking about a, bowel surgery or colon surgery is very common in robotics. 3D printing is not yet really entered these markets because we're really 3D printing either surgical guides or implants, and those implants tend to be associated with bone. So at the minute, robotics has got a lot more use around soft tissue areas, whereas 3D printing tends to, at the minute, mostly be around bony areas. I think that'll change. I think that we'll get into a stage where medical devices, for example, let's say pacemakers or heart stents or vascular stents, will be much more personalized. And in order to personalize them, you're going to need a 3D printer of some kind. So I think that at the minute, one of the limitations around 3D printing is most of the time you're talking about bones.
Okay.
And when it comes to robots and limitations, definitely used cases. We
Okay.
have to define the use cases. We have to define the technology, robotic technology. Now we do know that lasers and robots work well together. So that seems to be one area. And the Da Vinci is an extended arm that also works very good for certain tasks in hospitals. And
Okay.
we do know that certain robots have certain advantages in specific body parts. So I think it's also understanding what is the added value for a hospital. But till we're there, that'll take many years. And in the meantime, it's definitely 3D printing as such. So the limitations are the high price, the skepticism, and it's big institutes and hospitals like ours that are doing the research that is necessary to take it to the next level and to understand basically what it's all about. But that's something that will take time. It's not something for a mid-sized institution that doesn't have a research background and doesn't have the financial backing to just buy a robot and have it. That's absolutely not what I think would be advisable. But in the near future, the big hospitals and when these case reports are there and we know that they work, then it's definitely an interesting thing to have. And when the use cases make sense also financially for the hospital.
Okay. What about patient feedback?
Well, because we're a medical device company, I don't get as involved in patient feedback because we're kind of one step away. But when we do get involved with it, there's been a case, if you look it up on the BBC and on the Alder Hey, which one of our big hospitals is Alder Hey Children's Hospital. We made a model for a little girl called Leah Bennett. Her dad happened to work in the NHS as well. And so he was happy to publicize this case. You can find it very easily. And the patient feedback there has been transformative. This little girl's alive, basically, because of the model that we made helped the surgeons. Look, the surgeons did the work, wasn't us. We just did the planning for them. But at the same time, you speak to the surgeons who did the operation. They weren't going to carry out the operation until we'd done the virtual plan. And they weren't going to carry out the operation until we'd made them a sterilizable model they could take into theatre with them. And this was the resection of a massive grapefruit-sized tumor inside this girl's chest. And so in terms of patient feedback, whenever I'm feeling like I need to justify what 3D Life Prints does for a living, I send them the use case of Leah Bennett, and everyone's very pleased that we're saving little girls' lives.
Okay.
I think when it comes to patient feedback, it's important maybe in the future to also discuss and also give the patient some kind of idea what's going on and show them, be part of the virtual planning, and maybe have them see exactly what it's all about. Because at the moment, it's these kind of surgeries, they have no idea what's going on in the background.
Okay.
And the operations are usually very predictable nowadays. At least a lot of these operations are predictable. And it would be important to also show and just, have a little bit of data that the patients would understand, especially children, what's going on, what's happening, what are we using. And we maybe find little toys that we can use and things like that. So I think 3D printing also, we have to kind of make a patient version that they understand what we're doing, or give them a little kind of PDF or whatever you'd like to call it, and that they understand it out of their content. I think too little has been done in that area.
Yeah,
Okay.
I mean, we have to say we've made for our patients, we've made miniatures of the models that we made for them, where they've
Perfect.
had we've had the surgery carried out, and I can think of one in particular. A young girl had a tibial plateau fracture on her leg, and we made a model of it, and the surgeon did the model. It all went fabulously. And then she said, "Can you make me a model of it?" And she has it on a keychain around her neck. I mean, that's happy to do it. Obviously, it's really nice because we've already done the segmentation. But you're right. There's definitely an engagement with patients. With my lawyer hat on, I'm screaming and worried about negligence, because once you tell a patient what you're going to do and then it doesn't happen, hey, they're going to sue you. But so you've got to be a bit careful what what you're giving away. But again, as a patient, as a potential patient, rather than the lawyer, I want to know what's going on.
Yeah, that's right. That's right. And speaking about law, the next question is about regulations. So is there today a particular commitment to the use of these technologies, or only the consent of the patient is enough? So still from the audience in the Q&A chat for you. So who wants to go ahead for discussion?
It's definitely Henry. It's definitely.
Yeah, I can say this one. It's fine. I'm very pleased to answer this one, because regulations are the most important part, in my opinion, of medical 3D printing. So the regulations are the medical device regs. So it's the MDR. They govern all manufacture of medical devices, and that means all 3D printed devices. If it's a medical device, just because it's 3D printed doesn't make it any different to any other medical device. It still needs to go through all of these different medical device regulations, and that means it has to have a technical pack, it has to be verified, that you have to have the right kind of quality assurance in place. There's a whole heap, a whole thousands of pages of regulations on medical devices. They all apply to 3D printed devices, and that includes anatomical models. And I wish that even half of the people that are making medical devices around Europe and the UK were aware of this fact, because a lot of them are making devices without having full knowledge of or care around the rules that apply. And the rules are there to protect patients. The rules are there to standardize and make sure that what hospitals are doing is correct. Now, if a hospital follows all those regulations, that's great, no problem at all. But if it's not following those regulations, it basically shouldn't be making medical devices itself. That's my very black and white opinion about medical device regulations.
Okay, and you were talking of, your point of view is about the UK, right? Or are you talking about it generally? Because I believe Ian has a different point of view on this question.
You probably will have. That's why I wanted to get in first. So the UK is actually behind the EU. The EU's moved ahead of the UK in terms of MDR. We didn't adopt the MDR, more fool us, in my opinion. We should have adopted the MDR had we not done that stupid thing called Brexit. But because we did, we're stuck on the old rules, which means our rules about manufacture of patient-specific devices are a bit more lax.
Okay.
Whereas in Europe, they're pretty stringent.
Okay. Yeah, can you please talk about how is happening, what's happening in Europe or in Denmark especially? I don't know if that's the same.
The regulations are still in limbo. It's still a problematic area to discuss, and there's a lot of different companies and institutions that are actually producing their own constructs. Some people are going the official way, some people are not going the official way. I think there's a large part is obviously the printing industry is also trying to push this whole idea into the market, which makes it, and many companies are just saying, okay, use this, and about toxicity and all these other different things, there's very little discussion. So I think there's, before even going into deeper detail, I think there's a definitely need to kind of consolidate. But what's happening is the market is consolidating itself. So only professionals that really know their stuff are nowadays producing constructs. So I think there are serious companies, and that's very important to understand the amount of effort, the amount of money they put into it, and the amount of steps that are necessary to get a good product. That's something that I would say that big serious companies are actually doing it. Nevertheless, the hospitals are now trying to build up their own point of care, so they're trying to take over and do a little bit of their own printing and things like that. But to be honest, the market is very, very split when it comes to quality assessments, assurances, and regulations. So I think there's a lot to be done. There's good, and there's also bad cops, as they say, or whatever you'd like to call them.
Yeah.
And that's how I see the market. And the regulations are there, but they're not that clear yet that we can really understand step by step exactly what has to be done. And I think that's something the European in Brussels, they have to really rethink about certain structures and make it a little bit more simple to have to build up a guide system. So I think that would be important.
Okay.
So there's been, interestingly on this, I actually wrote an article in 3D MedNet. Sorry, it's a competitor type thing, but about point of care medical 3D printing, comparing UK, EU, and USA recently. And so I went through all the different stuff and set it out, not in too much detail, because as you say, Jan, a lot of it is still a little bit grey area. And the tricky thing in the EU is, of course, so the regulations have been published. The regulations are black and white, but how each country interprets those regulations is going to be different, right? And so Denmark, which is one of the examples I used in my article, have some good advice, actually. I mean, it's not really very, very clear. It's still talking about generalities rather than specifics. But there is a little bit of advice from the Danish, I don't know what they're called, actually, I've forgotten just off the top of my head. Anyway, it doesn't matter. So the Danish articles are a little bit more detailed, but there's still a bit of like, so for example, if I say hospitals can't transfer devices between to other hospitals. That's one of the things
exactly
written in the articles. But the Danish system is interpreting hospital to mean hospital system. So hospital systems can transfer devices between the hospital system. So, which one's right? I don't know, but it really matters. And it says again in here, you can't manufacture in-house a device that can be procured commercially on the open market. And again, the Danish system, to use your example, has interpreted that as saying it has to be exactly the same device. And so therefore, for a custom-made device, there's never a similar one on the market.
Okay.
And we have a pretty tight interpretation of the wording. So therefore, I think that it will fall out in the next 2 years or 2 or 3 years as the MDR gets interrogated by a load of lawyers, by a load of hospitals getting sued, and a load of other things will happen that will clarify a lot of these rules. But one thing is certain from my point of view is there are rules there, and they will tighten over time.
Okay, great. Thanks, Henry.
Subject.
No problem. Let's move to the next question in the Q&A chat, if you don't mind. So this one is from Steve. It's quite difficult to find many application cases. From my research, I noticed that urologists and orthopedists seem more interested in exploring robotic surgery and personalized 3D printing. Why is that? Any specificities with these fields of the healthcare industry, or is it just easier in your field?
Yeah, this is definitely one for you.
Yeah.
Yeah, that's for you.
Yeah, as I said before, it's not easy to find the application. So when robotic surgery started many years ago, and there are certain robotic devices, slave arms that we're using now, they basically have excellent grabbers, so they can grab. So it took quite some time to find out what could you use this robot for, and that's what we're in this process of understanding what tasks, and urologists found out quite quickly that let's say slave arms and grabbing tools are very interesting to put into the small cavities and grab something, the prostata, and also in the urogenital area, and pull little objects out so they could travel inside and pull certain things out at a high precision. Lasers are more important to do certain cuttings. And as I said, we're in the process of understanding where can we use like laser robots and in the future other drill robots. It's us to find exactly which areas of interest. Surprisingly, robots do exist, and they exist in the car industry everywhere. But it's important now to really define, and that's probably something that I'm going through, is I'm scouting for areas where you could use a robot. I'm scouting for areas where you can't use a robot. And then I'm also trying to identify what kind of robots could be used for specific tasks. Okay. So we're at the beginning of this whole technology, and that's why it's difficult to say all of a sudden this application is probably what you're going to use. We don't know. Sometimes people come up with new ideas. So I think we're at the beginning of an era, and we just found out that specific tasks, especially in urology, are very, very interesting for grabbing robots. The other one is cutting robots using lasers. The other one is using drills. So all types of systems and all types of different technology requires a different use cases. So use cases are probably the thing that we're looking at as we speak, and then also defining new robots that would fulfill these tasks.
Okay. And for use cases, people need to be sick.
Yeah.
Sorry, that's a bad joke. Sorry. Yes, anyway.
In 3D printing, you'll see, it's no surprise at all that Jan's a CMF surgeon, honestly, because if you're in 3D printing and medical 3D printing, that's where it kind of started. You'll see CMF departments across the world utilizing 3D printers. And I think the reason, although I may be putting words into Jan's mouth here, is because of the requirement for precision. The requirement when you've got a jawline, if you're out by a millimeter and you're implanting someone's hip, no one's going to really care. I say that because you don't look at someone's hip very often. But when you've got someone's jawline, that people are very upset about having something out by a millimeter or away by by 5 degrees or whatever it might be. So because of that precision requirement in CMF surgery, that's where you saw this technology used first. And sometimes now when I go and speak to orthopedic surgeons or spinal surgeons, and we're talking about CMF use cases, and we're applying them into the other areas now. So cutting edge, for example, are now really quite common in orthopedic surgery. That's a relatively new thing. In CMF surgery, they're used all the time, like all the time. So I think that what we'll see is this trickle down effect of where use cases are used in one certain area, and then you'll find that they're used, more regularly in other areas as the technology becomes cheaper as well. Because if you can afford it, why not have a really perfect hip replacement? And if you're a sportsman, you certainly want a really perfect hip replacement, because that extra week of recovery is going to make a really big difference to you. So that's what I'd say about use cases, is they'll over time, they'll shift from the early adopter areas to the kind of later adopter areas.
Okay. Let's focus on that patient standpoint. So we all agree with the fact that personalization of 3D printing, allows for a better feed, less failure, and greater speed. But at the end of the day, advanced techniques to heal a specific, disease or to conduct a specific surgery remain, quite expensive for the patient. Can we envision a way to reduce these costs?
I mean, I think, I just start quickly. I think that the prices have gone down dramatically, and we are seeing now different software packages on the market. And I do believe machine learning will definitely play a very, very big role in the future when it comes to democratizing the costs and also optimizing the costs. Obviously, you would have to buy the machine learned tools, and the software packages will have wizards that are specifically for one task of interest. But I do believe that the future lies in smart software that you can adapt for your specific task of interest. You maybe don't need to buy a whole big software if you're only doing orthopedic surgery in the knee area or whatever, in the shoulder area. You maybe just need a specific thing. So I think in the future, companies, especially companies like Henry's, who are using already their own softwares, and they have all these different software types that they combine. That's how we do it. We combine up to 6 or 7 things. So that's how I see it.
Okay, so Henry, so you think that the price is going to be down moving forward?
I actually want to almost reiterate what Jan said, but in a slightly different way. I think that there are various different tasks within the 3D printing. I can only talk about 3D printing mostly at the minute here. This 3D printing workflow, all the way from uptake of data, engaging with the surgeon, all the way through until the device, whatever the device might be, in the surgeon's hand. And several slices of that workflow can be very much automated. For example, the segmentation piece. Segmentation is the first stage where you take the scans and then you resolve them down into the bit that you need in a 3D format. That bit there can be automated a lot. At the minute, it's still very, very manual. And Jan will have biomedical engineers going through doing that process. And it's a time-consuming, relatively boring, but very important process. And so that process there can be automated within parameters. You'll still have to have someone look at it probably for a long time. And there are other various things in there, just as Jan said, for a particular type of, let's say, a cutting guide for shoulder surgery, of which there are several on the market. If you have an algorithm which picks up the relevant patient data points for that particular anatomy, then you can pre-design a whole heap of the device. That means your engineer who's designing it only has to spend half an hour on it rather than half a day on it. And so at the minute when we sell something, more than 50% of the time, therefore cost, is design time. Manufacturing cost is less than half of the cost. So if I can take the design cost down, and at the same time, hopefully in the future, the cost of the manufacturing will come down as well, then we're going to lose 50% almost of the cost of these products. So that's what I think is the automation that Jan was talking about. It will apply in several different bits as you go through the workflow.
Okay, we have 2 more questions in the Q&A chat. The first one I'm reading is the one from Taiwo. So what's your view on using 3D printing for prosthetics and orthotics? Talking about the use case, printer cost, unavailability of filaments, and financial needs. I have a project I'm working on here in Nigeria, similar to using 3D printing for medical devices to make it affordable, but it's been hard convincing my colleagues, being the first person to start this in Nigeria, and it's difficult journeying alone in terms of the funding. I don't know if you might be of any help to this question.
I have a little thing I can say on this actually, because 3D Life Print started as a prosthetics manufacturer in Kenya. Actually, funny enough, that was the origins of our company. was as a charitable company making 3D printed upper limb prosthetics. And we got out of that because it was so hard. It was so difficult to do because, and we chose the easiest of the prostheses. So if you have a weight-bearing prosthetic for the leg, it's a very tough thing to 3D print cheaply. You can probably make them expensively using an EOS printer, using very, very high quality printing. But otherwise, you've got to have something that's really tough, that's really going to survive the wear and tear. So what I'd say to Taiwo is, this is not an easy journey at all. You can probably make some stuff, but whether or not it's going to be better than something that's made traditionally, at the minute, we struggled with that as 3D Life Prints, honestly. We still do some projects around this from time to time, but as part of our our greater outreach, not as a commercial entity, but realistically, it's quite a difficult thing to do, to make something that's as tough and durable as something that's made traditionally.
I have one point on that. I mean, I also grew up in Africa, and I think one of the major issues is also to find traditional means of optimizing the 3D print environment, especially like making models. As you can see, these are the kind of models. And I know that you can make it out of maize and all kinds of different things. I think we have to also try to, first of all, also assess the situation and the opportunity we have to print different products using different clays or whatever. I don't know about that. That's something maybe to look into. Obviously, the software part and that is something that has to be bought. But I think it's also time and an opportunity for people in Nigeria and everywhere, which is a huge economy, is to also obviously limit the costs by maybe do the planning yourself, and then having a company like Henry's do the production of the construct, at least show what you can do. But I think there's also an opportunity to liberalize the system by looking at printers that would just make models. And that's something that shouldn't be that difficult to do using raw materials. This is just a kind of innovative way of solving problems that you face. But I think the smartest thing, and this is what everybody's doing, the manufacturing part at the moment is expensive and complicated, and these machines require a lot of experience and they cost a lot. I'm talking about the printers. So it's not going to be that quick till we find solutions that are cheap enough. But when it comes to just making models, like this is a gypsum model, a gypsum printer, I think there's opportunities now to also think about developing own materials, and I think that's something also to think about.
I would say, just on the cost of printers, I've been quite surprised and pleased by the cost of printers coming down. Certain types of printers, some are still very expensive, of course, but there are some really good printers out there. I'm going to shout out two because I know no need to, but I think they're amazing. One is the Formlabs printer, which is just an incredible piece of kit. Right, we use them all the time. So people say Formlabs is a desktop printer. It's an amazing desktop printer. And another great printer is an Ultimaker. Again, very reliable. Don't print that often. And I think that I shout those out not because I get paid for it, but just because I think that actually, if you want to buy something, it's not going to break on day one. Those are two great printers, and they've got very good resolution as well. So there are some good, and the cost of those printers is somewhere between like $1,000 to $4,000. Not cheap, in no way cheap, but then you don't have to spend $150,000 on I'm not going to say the names of those printers, but there's a lot of printers out there that cost a lot of money as well.
Yeah. One last point, I think it's absolutely, they're precise for small constructs, but if you need large-scale prosthesis, orthesis, and things like that, then you need durable materials and you need a big workspace. And that's something that the VAT space doesn't allow big constructs to be printed, and that's probably one of the big tasks that is a problem. But at the moment, they're actually 3D printing houses, and I think the materials that they're using are cemented, certain type of cements, and it seems that the results are quite good when it comes to building houses with 3D printers.
Thank you. I think that we'll take this last question from Mike. We just have 5 minutes left before the end of our panel, and I hope all of the responses of the speakers have been useful to you so far. So let's take this question from Mike before sharing our concluding thoughts for this topic. There are a lot of data involved when we leverage digital technologies. Who owns these data? Medical device manufacturers or hospitals? So that's something we've addressed at the beginning of this conversation. So Henry.
So that is a super question, Mike. That is a super question. So I also like that you wrote these data because you understand English beautifully as well. So what I'd say is it is a bit up for grabs here. It is a bit that, hence all good questions talk about something that's not completely black and white. So in my opinion, the DICOM data is inarguably the hospitals or the patients. I don't care. That's not my problem. So that's the scan data that comes out of the hospital. That's Jan's data or the patient's data. It's not my data at all. They basically lend the data to me in order to construct a patient-specific medical device. I use the data for its purpose, and then I return the data to the hospital. We destroy the data, that original DICOM data. So I think that bit, in my opinion, is pretty clear. The next bit, though, is I've created an SDL file from that data. Okay, the SDL file I've created from the DICOM. Well, unless you've got a contract, it's arguable that data is my data because I've created it. Now, I'd be very happy to sign, and I sign contracts with hospitals all the time that say that actually that's their data, and again, they're just lending that data to me, and I won't use it for commercial purposes and all these other different things that I can't do with that data. But in that case, what's interesting is you have to track the jumps of the data between its various different forms and not just work out who owns the data, but who owns the next stage of data that's created from the original data. And so on, because there may be 2 or 3 steps. So, for example, who owns the cutting guide design file? I mean, I'd say that was me, and I hope no one would argue with that. So I think that what is a really interesting question about who owns this, and every time that a hospital engages with a medical 3D printing company like mine, they should have a contract which sets this out.
Interesting. Jan, do you have a different point of view?
I think it's absolutely the same, but nowadays there's something new, and that's a new area, and that's machine learning. So what's happening is that a lot of people, the more data you have, the more you can learn, and that's also a development. And the interesting thing is the industry doesn't have the DICOM, and the hospitals don't have the STL files as such. They do in a certain case and everything. So I think it's a with any field where you're interacting with a company and certain parts are being done outside of the hospital, it's anonymous usually, and if you destroy the data, and that's basically what I guess all companies do, the DICOM data, you still have raw data, but you cannot track it to a patient or things like that. You shouldn't be able to, at least in a context. Obviously, the companies sometimes have their name, sometimes they don't have, but it's a like, let's say, a workflow life cycle in its own. Nevertheless, there's a new area, and this is a little bit of the tricky area. It's called machine learning, where there's an opportunity for both parties to interact with the data and optimize their algorithms. So that's something that's new, that is also a little bit of a tricky area, a little bit of a gray area.
Absolutely, and you're right, absolutely, because we could really use that DICOM data. We could really use it, over a period of years and years and years to drive our algorithms to work better, of course. And so there's quite a lot of demand in the market for that DICOM data, but yet hospitals are unwilling to give it up, quite rightly, because it's belongs to the patient, belongs to the hospital. So you're right, there's definitely going to be some conflict there. But if we want the market to move forward, it's going to have to be utilized in some way.
Okay, thanks. So we have 2 more minutes before the end of our conversation. Do you want to share any concluding thoughts, any other key insights which matter for this topic? So I will start with Jan, and if you have any questions for Henry, maybe this is the moment for you to ask it.
I'd like to keep it simple. I think 3D printing really works nowadays. Stick to professionals, get professional help, interact with them. And at the end of the day, robots are at the beginning of their life cycle, and I do believe in the near future we'll have opportunities for specific tasks, like we've seen in the area of urology, where robots are being applied on a routine basis. So that it comes to an end, that it works, and I'm so happy to see that this technology is being used, and we have to democratize it, and especially in Nigeria and things like that, we have to find solutions for everybody. Thank you.
Thank you, Jan. Henry?
My thing is going to be a commercial thing, because I think what we're seeing at the moment is both technologies moving from kind of academia and within hospitals and through into the commercialization stage. And I think one of the jobs that mine and other people who run companies like mine is we have to take these technologies out of academia, where it's kind of and leave the development of the technologies in academia, but the deployment of them should be a commercial matter, and I think that's what we're trying to do. And I'll just finish by saying, so that's kind of what we do. We supply these as services now, and it should become a normal thing, like like ordering a hip from Depew, sooner or later. No one thinks about making one of those in a hospital because it just makes no sense, because the price differential and the expertise and all the rest of these things. That's thing number one. But also, in order to make that happen, we have to look at how the things are reimbursed and work in the hospital payment systems. For example, I have never been paid by the NHS for any of our products. Hospitals are paid because they like them and they want them, but the NHS, wonderful they might be, have never yet managed to pay me for one of our products, even though I've been running this company for the past 6 years. So in order for the market to work and get going, it's a bit better in Europe, actually. They've moved along a bit faster than we have. We have to set up the constructs so that these markets are understood and funded in the normal way, like other products are. At the minute, it's still seen like wizardry and research and development, which really we're not. We're in the deployment stage of this technology.
Thank you, Henry. Well, this is it. On these good comments, I would like to thank you both for being part of this session. Thank you to our audience for joining us on this day, for sharing their thoughts and questions. Stay tuned for the next panel that will be announced soon, and stay safe wherever you are in the world. Thank you very much, gentlemen.
Thank you.
Thanks.
Have a nice day.
Have a nice day.
Nice to meet you, Jan. Nice to meet you, Katie.
Yeah, pleasure.